Today's video is on section 4.5, integration by substitution. The homework is 1 through 37 odd. Tonight I am trying a different way to record this video through my iPad, so please let me know how it works. Anyways, let me cover up some of this. Integration by substitution. We're going to be integrating, which means taking the antiderivative of composite functions by using U-substitution when possible. For example, you need to be able to recognize the pattern to see if it will work. So we're going to use U-substitution to integrate when I have composite functions. Otherwise, I won't know what to do. I will not be able to integrate it. So this is a technique when I cannot integrate and it happens to be a composite function, which means one function inside of another. Like this, we can use U-substitution. So let's take a look at a couple of examples. Here's an example. We're going to integrate 2x times x squared plus 1 to the 4th power dx. So as I work through this problem, you'll start to see what pattern I'm talking about. So we're going to use a U substitution. We're going to let u equal this x squared plus 1. Now I'm going to take the derivative of both sides. Derivative with respect to u and derivative with respect to x. So u goes to du, and because the derivative of u is just 1, and then derivative of x squared plus 1 is 2x dx. So now I'm going to substitute. Now let's substitute. So I'm going to substitute a du up into here wherever I see a 2x dx. So that's the 2x dx will be substituted with a du. This x squared plus 1 will be substituted with a u, so we'll have a u to the 4th power, and take a look at what I have. Again, how did I get that? I let u substitution. U was the x squared plus 1. When I take the derivative of both sides, so now I'm going to substitute out my 2x times dx, my 2x times dx, that'll be my du, that's this. And u is the inside, the u squared plus 1, so it's now u to the 4th. So now I can take the antiderivative of this. So that's u to the 5th over 5 plus c. And now at the end, I go back and I substitute what u was. It was x squared plus 1 to the 5th power divided by 5 plus c. I was able to integrate. How did I do that? By U substitution. Let's do a couple more. So here's the next one. Just refocusing. So let's take the antiderivative of 3x squared times the square root of x cubed plus 1. Well, if I let u equal this, when I take the derivative, I'll end up having 3x squared. That's the pattern I'm talking about. So we'll let u equal x cubed plus 1, what's underneath the square root. When I take the derivative of both sides, with respect to u and with respect to x, du equals 3x squared dx. And again, when I take the derivative of 1, it just goes away to 0. So now I can replace my 3x squared times dx with a du, and everything underneath the square root with a u. When I do that, I get this. That I can actually take the antiderivative with. So it's u to the 3 halves divided by 3 halves plus c. So I'm going to multiply by the reciprocal 2/3. I'm going to resubstitute back in what my u was, plus c. And I'm done. Let's try another one. Let's try one with trig. So I have to take the antiderivative of secant squared x times tangent x plus 3 dx. Right now we have no tools to be able to take the antiderivative. So what I'm going to use is I'm going to use U substitution. So I have to be able to recognize this pattern. I have to remember that when I take the derivative of tangent of x, I end up with secant squared x. So it makes sense that I let this part be the u. When I take the derivative of both sides, that's du. Tangent of x becomes secant squared x, and then the derivative of 3 is just 0 times dx. So now I'm going to substitute this secant squared x times dx, all with the du, and this whole thing will become u. So now it's just the antiderivative of u times du, which is u squared over 2 plus c. I go back and I resubstitute, that's 1/2 times tangent x plus 3 quantity squared plus c. Now I'm going to do a couple from each of the sections of your homework. Homework 1 through 6. And so it does not want you to integrate all the way. It just wants you to practice finding the U-substitution and then taking the derivative of both sides, which I forgot to do here. And so if I let this be the U, then the pattern will be when I take the derivative of that, I'm going to end up getting an x squared. So I take this u, I can go ahead and get this, except that doesn't exactly replace it. What I need to do, and I did not show that, is I want it to be only x squared times dx, so I need to move this 3 to the other side. So I'm going to divide it. So now it says 1/3 times du equals x squared dx. So the x squared times dx will be replaced with the 1/3 times du. But I'm not going any further with that, and you'll see a couple of those in a moment. Number 4, antiderivative of secant to the 2x times tangent to the 2x. Well, I know the pattern that when I take the derivative of tangent or secant, either one of them come back with a square, so that doesn't help. So I'm going to let my u substitution be 2x. So u equals 2x and du equals 2 dx. And so, again, I don't want that 2 there. There is no 2 here on the outside. I can't get that on the inside. So 1/2 du equals dx. So I'm going to take out that dx, make it 1/2 du, and then all of this would be secant of u and tangent of u. That I can take the antiderivative of. Homework 7 through 34. It says to find the indefinite integral and check by differentiation. So this time we're going to go all the way, but we're going to go back and we're going to check to make sure we're correct by differentiating it. So let me cover that up just a little bit. So I'm supposed to integrate x squared minus 9 quantity cubed times 2x dx. I cannot integrate that. I don't know how to do that. And I don't want to multiply all that out to get individual terms. So I'm going to U-substitute this x squared minus 9 because I know when I take the derivative of it, I'm going to get a 2x because it goes down 1 power. So I'm going to let u equal x squared minus 9, in which du equals 2x dx. Now I'm going to substitute. So 2x dx is my du, and the x squared minus 9 is my u, so it's u cubed. That I can take the antiderivative of. That's 1/4 u to the 4th plus c. Now I'm going to go back and resubstitute what u was, x squared minus 9. Now let's go and let's do our check as our direction state. Check by differentiation. So we're going to go ahead and take the derivative of this and see if we get back our original function. Check. So I'm going to take the derivative of this whole equation with respect to x. So as I take that derivative, and yes, I made a mistake there, that 1/4 just sits there, so I have a chain rule. I bring down the 4, x squared minus 9 to the 3rd power. Then I take the derivative of the inside, so the derivative of the x squared, which is 2x, and then the derivative of any constant number, 3, 5, 2, is just 0. That's why there's nothing here. Now I'm going to proceed to clean this up. So the 4 times the 1/4, that's just a 1, and I'm happy. I got my original function. So I guess this was correct. Let's do another one from your homework. I'm sorry, I'm doing the evens. Yours is the odds. Number 20. I'm going to take the antiderivative of x cubed over 1 plus x to the fourth quantity squared. So if I let u be 1 plus x to the fourth, I know when I take the derivative, I'm going to end up with an x cubed. That's probably the route I want to take. So let's see what happens. So I'm going to let u equal the 1 plus x to the fourth. I'm going to take the derivative of that. du equals, well, the derivative of a constant is 0. So let's just bring down my 4, reduce it by 1. So 4x cubed dx. So my x cubed is here, my dx is here. I don't want the 4, so I'm going to make it go to the other side. I'm going to divide it out. So that's 1/4 du equals x cubed dx. So x cubed dx gets replaced with 1/4 du, and we can take the 1/4 out front of the antiderivative. And then the denominator, that gets replaced with the u, and it's u squared. That I can take the antiderivative of. First I'm going to rewrite it. Write down my 1/4, and so I increase it by 1 and divide by whatever that exponent is, plus c. I'm going to clean that up. So what is that? That means this is a negative 1/4, and I'm going to substitute this u, and it's going to go into the denominator, 1 plus x to the fourth to the first power plus c. So I think this is right. How am I going to check? By taking its derivative to see if I get the original function. So I'm going to take the derivative of all of this. I went ahead and I put that back up on top with the negative 1. It's going to be easier for me. I'm going to use the chain rule. And so I'm going to leave my negative 1/4, bring down my negative 1, leave the inside, and decrease this by 1. Then I take the derivative of the inside, again my chain rule, that would be 4x to the third. Now I'm going to go ahead and clean all this up. So let's see, the 4 over the 4 is a 1, negative times negative is a positive, so those are all gone. So the x cubed is on top and all of this is on the bottom, quantity squared, which is exactly what I got. So yay, I'm happy. Now from homework 35 through 38, which says solve the differential equation, I will go ahead and do one problem from here. So it will be given to you like this, dy dx, or in other words, the first derivative equals 10x squared over the square root of 1 plus x cubed. By solving this, we're going to take the antiderivative. So I'm going to take the derivative of both sides. In fact, it's putting the dx over here, and I'm going to take the antiderivative, so it's going to be y, and I'm going to integrate. So I'm going to use U-substitution with what's underneath the square root in the denominator. U equals 1 plus x cubed. Take the derivative, that's du equals 3x squared dx. So I have the x squared and the dx. I do not have the 3, and I do not have a 10. Well, that's easy. The 10 I can pull out in front, and this I will divide to the other side. Okay, so from right here, that all matches. So I'm going to start substituting that. I'm going to take out the 10. I'm going to put the 1/3 out front. So the x squared dx gets replaced with the du. And so it's 1 over the square root of u. That I can take the antiderivative of. So y equals 10/3. I'm going to rewrite this, u to the negative 1/2. So it's y equals 10/3 u. I'm going to increase it by 1. That's what you do when you take the antiderivative. 1/2 over that exponent, 1/2 plus c. Now I'm going to continue to clean this up and resubstitute the u back in as I do this. So it's 10/3 multiplied by the reciprocal, 10 over 1. Resubstitute back in my 1 plus x cubed to the 1/2 power plus c. Now I'm going to clean that up. So 10 times 2, that's 20 over 3. That's the square root plus plus c. And in the directions, they did not ask us to check, so I did not check except for the answer in the back of the book. Thank you.